In this video, we'll be talking about graphing the tangent function. Recall, if you haven't watched the video yet where we talk about the tangent function itself, you should go back and look at that. But a couple of things from that we observed was that we have issues at certain spots of the on the domain of tangent. So at these points right here, and we represent those. Those are infinite discontinuities. They're called vertical asymptotes. And the reason for this is recall that tangent of theta is the same thing as sine of theta divided by cosine of theta. So like it has this denominator, cosine theta. And so if cosine theta were ever 0, then we would have a problem with tangent of theta because we'd be dividing by 0. If you quickly just overlay, I'm just going to like kind of sketch in the graph, do it in green, in the graph of cosine on top of this graph of tangent, and put them there, and there. You'll see that the graph of cosine, when it crosses the x-axis, or when it has a 0, we have problems with tangent. And those are where those asymptotes line up. And if you kept going on and on, you'd see that, it does the same thing. So we have these problems. Now, also note, if we started off, we just said, okay, where does tangent start? Well, 0. If we say at x equals 0, at theta equals 0, the tangent of 0 is 0, because if you're thinking about a unit circle, okay, the tangent of 0 is 0. So right here, the coordinate is 0, 1, right? Sorry, no, it's not. It's 1, 0. It is 1, 0. So the y value divided by the x value there would be 0 divided by 1, which is 0, so that makes sense. Now also, as we get closer and closer and closer to 90 degrees, right, this is 90 degrees, we have very large values, because like the sine of this is like, the sine of like, imagine this is 89.99999 degrees. The sine is going to be, this coordinate is going to be basically 0.0001 and 0.99999. So it's like basically 0 divided by basically 1, it's basically 1 divided by basically 0, which is basically infinity. It's not infinity, right, because we can't have that. That's essentially a divide by 0 situation there. And so that's why we get that. And then as soon as it crosses over, see, these are both positive, and then over here, these coordinates, we have a negative positive value. So we'd have a positive divided by a negative there, or negative values, but we'd still have that same kind of really big value over here, so that's why we end up going down there forever. And so we also notice that the period, like how long it takes for tangent to repeat itself, starting there, it starts repeating itself again right there. So the period of tangent is just pi. It's not 2 pi like it was for sine and cosine. The fundamental period of tangent is pi. And the other thing that's missing here that we had in sine and cosine, we don't have in tangent, is the amplitude, right? When we had, I already drew in cosine before, but we had an amplitude. It was obvious to define what that was because it's like the maximum height, the maximum height above the midline. Well, for tangent, we don't have an amplitude, but we do have this nice point right here. And we have those nice points at 45-degree intervals, or pi over 4 intervals, because not every pi over 4, but the odd pi over 4 intervals. So we know that the x value and the y value at 45 degrees on the unit circle are the same. And they're the same for all the 45-degree values, right? So we have these nice values, either 1 or negative 1 at all of these points. And so if we wanted to do something similar to like we did with cosine, sine and cosine, where we broke them up into 4 equal chunks, we can do that here too. So right there, right there, right there, and right there, we have chunk 1, chunk 2, chunk 3, chunk 4, and the pattern now doesn't go like minimum, doesn't go like 0, minimum, maximum, whatever. It starts at a 0, then it has a nice point, then there's an asymptote, and then there's a nice point, and then there's a 0. And then we can draw in dotted lines to represent that it keeps going in that way. Sometimes you'll be asked to draw 2 periods worth of tangent, but I don't think that's necessary. But if your teacher tells you to do that, then you should do that. Let's look at an example of tangent now. Okay, right away, the amplitude, and I have that in quotes, is 2. The period, so 2 is omega, right? And the period for tangent is pi over omega. because pi is a fundamental period. So now we're at pi over 2, so we know the period is going to be pi over 2. There's no phase shift, right? X isn't being subtracted by anything. And then vertical shift is 2 up. So we got the vertical shift of 2 up. So we go 1, 2, 2. And we have an amplitude of 2. So we're going to be down at 0 and we're going to be up at 4. Okay, then we can draw that. Let's do tick marks. So tick marks are the same deal. We're going to take the period and divide it by 4. So we got pi over 2 and divide by 4. That's pi over 8. Okay, so the tick marks are going to be pi over 8 away from each other. The first one's at 0 because there is not a phase shift. So that means we've got 0. We've got, let's say this here is pi over 8. Let's say this here is this 2 pi over 8 plus pi over 8 is pi over 4. This one, next one would be 3 pi over 8. Next one would be pi over 2. And then we're good. Okay, now we know also that our first point, our midline, right? We have a midline. This is it here. Our first point is going to be at our 0. And then we're going to have that nice point, which is going to be an amplitude up. So at pi over 8, we're going to have 4. And then at pi over 4, there's a vertical asymptote here. This is a vertical asymptote at pi over 4. I don't know why my pen leaves these little lines, but it does. Okay, then we're going to end up going up. But then the next, so it's going to go up forever right there. It's going to come down. It's going to come up from forever down, if that makes sense. And the next point at 3 pi over 8 is going to be at the 0. Sorry, no, it isn't. It's going to be at the nice point, which is right there. Let me undo that. So that's going to be down at this minimum. Then our next point, our last point here is at pi over 2, at the 0. So let's sketch in what this would look like. So we have, it kind of does this very dramatic increase, and then it comes up. It's going to pass through that point right there, and then it's going to go to there, and this would keep going up just like it did over there, keep going down just like it's doing there. So that is how you would graph one period's worth of tangent. Let's look at a more difficult problem now. Okay, so the amplitude on this one is 1. There's not really an amplitude. It's in quotes. The period, okay, omega is 1/3. So period is going to be t is equal to pi divided by 1/3, which is going to be 3 pi. Okay, the period is 3 pi. Their phase shift is pi to the right. The vertical shift is 2 down. The tick marks, they're going to be, we take the period and divide it by 4. It's going to be 3 pi over 4 away from each other. And are we starting at pi? So our first one's at pi. If we add 3 pi over 4 to pi, we're going to get 7 pi over 4. If we add 3 pi over 4 to that, we're going to end up with 10 pi over 4. If we add another 3 pi over 4, that's 13 pi over 4. And then 16 pi over 4. And we can simplify these, right? 10 pi over 4, what is that? That's 5 pi over 2. And 16 pi over 4 is just 4 pi. Okay, so we're going to go from pi to 4 pi, and we're going to have all these different marks. And we're going to go, we have a vertical shift of 2 down, so on the y-axis, let's say there's our 2, then that's, so negative 2, there's your negative 1, and this will be your negative 3. So your midline is along y equals negative 2. First tick mark, we'll put that here at pi. The next one will be at 7 pi over 4. Next one will be at 5 pi over 2. Next one is 13 pi over 4. Next one is 4 pi. All right. So let's just do let's do the pattern. So we start at the midline. Our next point is going to be a nice point, and then there's going to be an asymptote here, and we'll draw that in a minute. Then our next point will be at our nice point at the bottom, and then we'll be back at our midline right there. Okay, the vertical asymptote is at 5 pi over 2. So there's your vertical asymptote. Man, I cannot draw a vertical line on this. Okay, and then sketch it in. So it's going to go this. And it's going to come down here, and it's going to go like this, and it's going to go up. This is going to go down, and there we go. That's it. One final example. Okay, here we have the amplitude is 3. The period is going to be, so t is equal to 2 pi over 1/2, because omega is 1/2, so that's 4 pi for this one. The phase shift is pi over 4 to the left, and there's no vertical shift. Okay, so let's put on tick marks. Tick marks here are we had 4 pi over 4, so that's pi. They're going to be pi away from each other, and we have a phase shift of pi over 4 to the left. So our first one's going to be at negative pi over 4. Then we're going to add pi to that, so we'll end up at positive 3 pi over 4. Then we add another 4 pi over 4, so 7 pi over 4, 11 pi over 4, and finally 15 pi over 4. Yucky tick marks, but that's fine. Okay, first one we'll do, we'll say it's here, it's negative pi over 4. The next one will be here at 3 pi over 4. The next one will be here-ish at 7 pi over 4. The next one, say it's there at 11 pi over 4. And then 15 pi over 4. Okay, and we don't have a vertical shift, so that's nice. The amplitude is 3, so we're going up to 3 and down to negative 3. And now the one thing we haven't addressed is this negative sign out here, and that's a vertical flip. So we're going to start in the same place, because we're starting at 0, negative 0 is just 0. But instead of going up to start with, we're going to go down to start with. It's like we took the tangent curve, and then we just flipped it upside down. So let's do the pattern. We're starting at the 0. The next tick mark here, 3 pi over 4, is going to be now down instead of going up. Then there's going to be this vertical asymptote at pi over 4, or sorry, 7 pi over 4. I can't read my own writing. Then there's going to be a nice point up at the next tick mark, up at 3. It's going to be up at 3, and then we're down to 0 here. And all we have to do now is sketch it in. So this would do something like, oof, let me redo that. Didn't have my arm in the right position. Okay, still not good. Whatever, I'm not going to be able to do that well. Okay, so that's going to go down like that. And then this was starting way up here, and it's coming down, and it's going to do something like that. Okay, and it's going to keep going, and it's going to keep going. Okay, ideally you could do a little bit of a better job drawing the curves than I can, but it's just, the tangent is a very difficult one to kind of draw with any sort of accuracy. But if we get these nice points, we can sort of draw in this concavity here, and as long as we have the points, everything should be fine. So on your graph, you should draw in the asymptotes, and you should draw in those 4 points, or in 4 points for tangent, and there's like 5 points for sine and cosine. And that's it. It's the same process for all the tangent graphs. Keep in mind, you got to make sure you're paying attention to your negative things. Just go through the process of getting the amplitude, the period, the phase shift, the vertical shift, find your tick marks, put them on the graph, and then you're done.